So first of all, thanks to Stefan for the great talk on Rails performance and for saying multiple times that Ruby is slow, so I don't have to repeat it. Because my talk is related to performance too and some weak parts of Ruby. Some quick introduction. I'm for the first time here, so my name is Vladimir and I came from Moscow all the way, and I think I brought the snow to Wrocław. Sorry for that. I haven't expected the weather like this here. I hope to travel to the spring weather, but all the same. Apart from programming Ruby and Erlang and Golang and Crystal and whatever, I'm doing a lot of open source stuff. You can find me on GitHub and Twitter. It's my technical Twitter account. And I'm working at a company called Evil Martians. It's our logo. It's pretty fun. Well, we're doing a lot of great stuff. So we're working for big companies and small startups doing product development. We're doing a lot of open source. We write about it in our beautiful blog with cool illustrations. And that's it for the introduction, because we don't have enough time to talk about Ruby. So why I'm here? Actually, that's the reason why I'm here. So my organizers were looking for someone who have an experience with Action Cable. So this brand new, not so new, it's already almost 3 years old framework from the Rails family. And I'd like to tell you about its good parts and bad parts, and some stories, scary stories maybe, and about other cables that there are in the wild. So first of all, what do I mean by cable? What is this? By cable I mean any tool framework which allows you to build real-time web applications. And what is real-time? Sorry, working not that good. Okay, so by real-time web application is an application that allows user to receive information as soon as it's appeared and anywhere else in the system from other users without checking periodically for updates. So it's actually kind of asynchronous communication, and it's fast communications. There are some of examples of real-time applications. It's a pretty simple one, is a typical chat application. And we're talking about Ruby, so there are a lot of Ruby cables, Ruby solutions to build real-time applications. Some of them, I think, are already dead, but maybe someone used it. Some are brand new and no one knows about them. And the question is, and we were gonna mention some Elixir things first time, that usually, even being a Ruby developer, when you get a challenge to build something real time, Ruby developers often choose non-Ruby solutions because Ruby is slow, right? We already know that. And there are a lot of things out there. There are different technologies, and you build a microservice along with your Rails app to handle WebSockets, or you use a third-party service like Pusher, Firebase, whatever. And the reason that Ruby is not a good language for concurrent applications, right? So that's kind of by design. We got some limitations and global interpreter lock. And memory model is not as good as it could be. So that's a problem. But I want to ask a question. Once again, this is the same question. Would you like to choose Ruby for your real-time applications? Or you don't want to even try to do that? Maybe there is a chance that we can write performant concurrent applications using Ruby, not only in Ruby. And that's a question I'd like to ask during my talk. So, first of all, let's talk about action cables. That's our main subject. A quick reminder what action cable is. It consists of several parts. First of all, we got a server. That's a part which handles all the low-level WebSockets manipulations, so parsing WebSocket protocol, sending and receiving messages, etc. Then we got a broadcaster part. This part is responsible for sending messages to the clients which are subscribed to the particular streams. So just identified communication channels. And to write code for all that stuff, we got a kind of channels framework. That's a framework for writing your code. That's three main pillars of Action Cable. Apart from that, we got, of course, clients and client implementations, some built into Rails, like a JavaScript client, and some third-party clients for other platforms. Let's talk about good and bad parts of Action Cable as I see them. First of all, what makes Action Cable attractive for Rails developers, not for Ruby, but for Rails for now, it's that it's just built into Rails. You're doing Rails new, you got an application which is ready for real time. You don't have to worry about it. And one more thing here is that unlike previous solutions, pre-Action Cable solutions like Fire, event machine-based solutions, you don't have to run a separate Ruby process to handle WebSockets. Everything happens within your typical process, your Puma web server. It's Rec compatible. It's really easy to work with. So it's simplicity of first steps. It's cool. The second good part is the channels framework I already told about. Let me show some code example if you're not familiar with it. So it's a very Railsy way framework. It's kind of channel is a kind of controller for your WebSocket. So you manage access, manage subscriptions, whatever. And it's really good. And of course you got callbacks because it's Rails. And the third part is I already mentioned too. So we got a client that just works, and it's a little bit smarter than nothing because it handles connection problems and it knows how to reconnect and resubscribe when anything goes wrong. So it's again easy to use, easy to work with. But still, there is a question. Anyone out there use Action Cable? Or use Rails, maybe. Maybe there are no Rails programmers. Okay, that's not strange, actually. There are some problems with it. It's not easy to find a real life usage of Action Cable. But I found one, and I'll tell you about it. Let's talk about some bad parts, some missing parts. First of all, it's not a main problem, but we cannot skip it. Action Cable is WebSockets only protocol server. It doesn't have any fallbacks. You may say, well, who cares? At least 6% out there on this planet cares because they still use really, really old technologies which doesn't support WebSockets. And even in Europe, there are 3% of users. I don't know who they are. I don't think anyone from this audience. But they don't have WebSocket support on their laptops. Unlikely. I think that's kind of big, scary personal computers. So we should take it into account, but that's not the main problem with Action Cable, of course. Unless you're building applications for those 3%. And the main reason why people are afraid of Action Cable, one of the main reasons, is memory usage. And it's due to some Ruby limitations too. Just a quick example, very simple benchmark. We're comparing almost doing nothing, a WebSocket server, WebSocket application written with help of Action Cable and similar implementations written in Golang and Erlang, just to compare things. So, as you can see, the memory required for Ruby is much more than for others, and it became a little bit better since 2.5 has been released. For 2.3, it was about 20–30% more memory for Action Cable. But we're going to talk about memory when we speak about real-life example. Another main thing that is real-time performance. We were talking about page load performance previously, and there were some kind of milliseconds and so on and so forth, and context switching, psychology. So for real-time performance, we usually take into account the amount of time it takes for server to broadcast message to everyone who's listening to the stream. So how big is latency between something happened and everyone knows about it? For some applications, it's a crucial metrics because You don't want to write a chat application when your latency is several seconds because communication won't be good. So to measure it, we got a great benchmark written by HashRocket company, which actually measures this real-time performance. So we measure the time it takes server to broadcast the message to everyone, as I already stated. Let's see the numbers. Hey, pretty scary. First of all, we introduced a version of Action Cable with only 2 workers, the minimal possible for good work. And we see that for even a couple of thousands of clients, well, for someone it's too big. For high-load applications, it's not so large number. We see that latency grows very fast and it's dozens of seconds. It's unacceptable, actually. When we add more workers, say 8 workers, we got a 8 CPU cores machine for this benchmark. So latency is smaller, but it still grows, and it's much, much more than for, again, more suitable technologies. Doesn't mean that, well, forget about Action Cable, stop talking about it, let's talk about Erlang. I know, not sure. Not this time, maybe they're gonna be Erlang Wrocław conference someday, at least Elixir. It's possible to talk about Elixir on Erlang conference. Now, it doesn't mean that Action Cable is I know how to say it politely, so I just skip this part. So that's kind of cat theorem for cable, right? If you want to use Action Cable, you should either sacrifice your latency, or you should be aware of crowded channels. By crowded channels, I mean channels which had a large number of subscribers, say thousands. So if you don't have such case, if you use an Action Cable to broadcast dozens of clients, it's okay to use it. There is no problem from the real-time point of view. It's good enough to work with. That's it. But if you want to handle millions of connections, not even millions, but hundreds of thousands, and you want to have low latency, of course, that's not for you. And even Ruby not for you. And just last but not least, let me show you this quick GIF while I'm drinking water. Okay, so that's a CPU usage of Action Cable server under not so heavy load, actually. You don't have a room for anything else on this machine. That's a 16-core, I don't know, C3 4X large Amazon instance. Pretty expensive, actually. Well, but that's all about theory and benchmarks, and don't believe benchmarks, they're artificial. They don't tell you about real-life usage. So it's kind of, experiments, academic research, whatever. Let's talk about real life, and I want to talk about a service called Quip.com. What is it? It's a platform for managing and monitoring equestrian shows. So it's that kind of sport with horses. I'm not a big fan of such sports, but it turned out to be very popular in Europe. The platform is heavily used WebSockets. First of all, for monitoring part of service. That's kind of textual translation of what happened in real time during these shows. A lot of shows happened during the weekends, and the load is pretty high, and I have thousands of connections. Well, I talked with the owners of this startup, and they told me the story. So they used different technologies, different cables, I call them, including Action Cable. Until they finally switch to something I call X for now, and review it in a minute. What is it? And according to Action Cable, we already told that memory is a problem in Ruby, and in Action Cable is much more a bigger problem, because to handle all that load, they have to use more than 21X Heroku dynos, each 1 GB RAM. So they host it on Heroku, and the memory will grow in their application very slowly due to memory quota exceeded exceptions, and everything was not so good. That was the situation with Action Cable under the high load. Then they switched to some other cable, and the amount of resources they need drastically decreased 10 times, because they now have 4 dynos, twice smaller. That's well, looks kind of fantastic. Of course, they spend much less money, 10 times less, for this configuration, and they have a room for more load, so it's kind of for future. And the question is, what is X? Any ideas out there? Maybe it's Elixir. No, unfortunately, that was not the case, because they get a large platform with a lot of legacy code, and it's all been written in Rails. And to migrate it to Elixir, I guess it's worth it a lot of effort. The migration to X took only a couple of weeks. That's good part of this migration, and the X is Anycable. And that's another cable I'd like to talk about today. That's a way I'd like to prove that it's possible to write concurrent applications with Ruby and something else. So, what is Anycable? There is a good definition by one person, probably know who it is. So it's a sound tool which allows you to enhance action cable, not to replace it, but to make it faster, to make it consume less resources, to make it better, actually. So let me tell you how we can accomplish this. So let's recall that we have 4 parts of our action cable, and actually the part which is responsible for all that poor performance and resources usage is a server, the part which handles all the low-level WebSocket stuff. Not the framework itself, right? Because framework is just a Ruby code and not doing anything much difficult. So what if we can extract this server part out of MRI, out of Ruby, out of our slow Ruby, and implement using different technology and connect it to Ruby? That's actually the idea that lies behind the Anycable. So with Anycable it's possible. But first, before showing how it works and showing sophisticated diagrams, let me tell you a few notes about RPC. Who are afraid of RPC? Raise your hand. That's a common situation that when I'm talking about RPCs, people, what? Here is an RPC. Where you came from? 90s? Well, yeah, that's a problem with RPC. It's a bad word. But we're talking about gRPC. What is it? First of all, yeah, we can call it a Google RPC. It's not an officially G is for nothing. They do not tell anything about G, just a letter. But we can call it Google RPC because it was born in Google. It is heavily used by Google services. You probably know about that because many of public Google APIs have gRPC versions. And it's a universal RPC framework. By universal, I mean that it's possible to easily build servers and clients and different languages and communicate with each other. And technically, we use HTTP2 and protobuf serialization, which is fast, which is binary protocol, which is fast in serialization, deserialization, and it's good in data compression. And HTTP2 allows us to make a lot of concurrent requests using the same connection. So actually gRPC is just a combination of those two technologies. Having this, we can build something like that. Well, a lot of components, but okay. Just a quick explanation what's going on here. Instead of connecting our clients to our application as with Action Cable, we connect them to some WebSocket server written in other languages, say Go. And then our task is to proxy all the Action Cable protocol messages to our business logic, to our Ruby application. So in that case, it's a RPC part. So that's a gRPC connection. That's just an instance of your Rails application, but with a different server, with RPC server. Everything else is available, so just a Rails application. And that's the way your clients communicate with the application. And there is one part which is called Redis, but it could be something else actually. The way we broadcast messages from our application to WebSocket server, which is responsible to fan out all these messages to clients. That's how Anycable works right now. Okay, we know some diagrams. Let's run our benchmarks again to see the difference between Action Cable, pure Ruby solution, and Anycable, Ruby and something else solution. Right now we got two implementations for Anycable WebSocket servers. One written in Go, another one written in Erlang. Don't ask me why there are two of them right now. After the talk, I'll be ready to answer this question. And first, well, just a quick comparison of CPU usage. It's pretty interesting actually in terms of comparing Erlang and Golang, because we can see that Erlang scheduler is much more better, because almost equal amount of CPU for every core is used, not as for Golang. It's kind of chaotic, but both of them are much better than Ruby, of course. As for real-time performance and our shootout framework, everything is clear too. So we got a much better performance. We can call it real-time. And what is the cost for using Anycable? So except from having a couple of more servers, right? It's not that easy. But despite from that, you don't need anything else. Just a couple of commands and your application is ready to be used with Anycable server. You don't have to rewrite your channels mostly. So we got some kind of compatibility table which shows that almost all features of Action Cable supported. Not all, so there are even articles describing subtle differences from users who use it in production. But apart from solving the performance and resources problem, Anycable brings us an opportunity to extend functionality, to do something else, some cool features I'd like to talk about. And the first such feature is, I call it zero disconnect deployment. Typically we know some kind of zero downtime deployment, but when we're talking about sockets, there is a notion of zero disconnect deployment. What happens when you deploy your Action Cable server, so new version of Action Cable application? You have to reload your web server. And when you reload your web server, all the connections got disconnected. So we got thousands of connected clients. They all disconnected at once, and they all at once tried to connect again. So first of all, there is a gap between this connection and when they got reinitialized, and you can lose some messages. And actually, that's another problem of Action Cable I'm not going to talk about today. We're going to talk about mostly performance. So another problem is when thousands of clients try to connect all at a time, your server won't feel good, right? Because it's kind of a peak load, which we don't know, can end up with something not so good. And with Anycable situation changed because we do have a kind of proxy WebSocket server, which is logicless. We do not have to reload it on deployment because it doesn't contain any logic. It's just some kind of enhanced proxy for WebSockets. So you can just reload your application and your clients stay connected. You don't have to disconnect them. Everything works as previously. This feature is very crucial for applications which are deployed, every 5 minutes, like big Rails monoliths like Shopify or maybe GitHub. They deploy in every time. And if you got to disconnect every minute, it's not good for real time. So that's just simplified diagram. There is a little bit more complex diagram of how it actually works to our configuration. We use Envoy proxy and a kind of rolling update. It's makes the process even more smoothly. No RPC errors or whatever. Another great feature, which is brand new for Anycable, is the one reason why I built it, as having advanced analytics. If you're working with again, high-load application, you should know what's happening inside. You should monitor what's going on to prevent some outrages. And with Anycable, it's easy. It's got Prometheus compatible metrics endpoint, for example, and you can build such good dashboards in your Grafana and set up alerts and, well, monitor all the stuff. At least know what is going on inside. How many clients do you have? How many unique clients do you have? So that's a quick overview of Anycable. We got a pretty beautiful site. You can check it. There are a lot of resources out there, talks and posts, and of course GitHub and Twitter. Let's stop with talking about Rails. No one interested in it. We got 5 minutes to talk about not Rails usage and some other cables. Any questions so far?
You mentioned that you can explain why there are two implementations written in Go.
Yeah, okay. The explanation is pretty easy. I haven't programmed Golang when I was trying to write Anycable first, about 1.5 years ago. I tried to write it in Erlang, but there was some problem because there is no gRPC library for Erlang. I had to write one by myself. But first I decided to build a really quick prototype in Golang, because Golang is pretty cool in writing something very fast. And for the last 2 months I spent refactoring all that Go mess that I wrote 2 years ago, because it was hard to maintain. Now I'm not supporting Erlang version because, well, frankly speaking, it's not easy for most people to use it, because Golang is pretty much more easy. Just download the binary and run it. That's it. And with Erlang, there are some additional complexities. And when I will use Anycable for my own project, not we'll use it on other project of Will Marshes. I'm not working for them. So maybe I'll try to use Erlang, because I know how to use some great features and enhance the cable protocol with it. But for usual Ruby developer, it's much easier to use Golang binary than to run Erlang VM with all its complexities. Okay, thank you. Let's the final part. It's a pretty short part, but it's kind of I want to show some other cables out there. And the story begins with the issue, again, in the Anycable repository. When I released it a year ago, one person asked me, well, I'd like to use it without Rails. How it's possible? And I thought, well, what make it dependent on Rails? Actually, just the part which is where we write our code, our channels, our Ruby framework. And I decided that's not too hard to build our own framework for channels, because I know how Action Cable works from the inside. I'm tried to make it better in the Rails repository by making a lot of pull requests. Most of them still not got merged, but including some which solve some performance issues, by the way. But having some ideas in mind, I built a project called Lightcable, and it, well, pretty obvious. What does it mean? It's a Rails-free Action Cable, so it implements the same protocol, but it doesn't depend on anything, not even active support. And it's compatible with any cable out of the box, so it was built for any cable initially. And it's compatible with all the Action Cable clients out there. And it's really easy to use. It looks almost the same as Action Cable, less magic, no callbacks, but the main features are supported. And it could be used even with rec, so you don't have to use anything else. You can try to write something real-time with rec, but it's designed to be used with any cable. There is a good example of usage of Lightcable and Anycable with Hanami framework for the Internet of Things project. So it's really easy to configure it and run, so you can use I call it Hanami cable because, well, Hanami doesn't have its own solution. I think it won't have one. It doesn't make sense. And right now we're working on one more integration. It's with a project called Plezi, and it's work in progress. I think we're gonna finish it in a couple of weeks. It's not as easy as we thought. What is Plezi? Plezi is a framework built on top of Iodine web server. That's a new alternative web server in the Ruby world. It's kind of alternative to Puma passengers or whatever. So it's just actually a wrapper of a C library for C framework for HTTP applications. It's React compatible, so it can be used to run your Rails application. And as being mostly wrapper over C, it's really resource efficient, so CPU efficient and memory efficient. But as for now, it's not as stable as I wish it to be. There are some bugs, but the offer of the framework is very responsive and calls on it fast, but there are some bugs in the wild. So there are two projects. Iodine is a web server, and the Plezi is a framework to write real-time applications on top of it. And having these two and making it possible, for example, to connect to Action Cable or to Light Cable would bring new opportunities to Ruby, because it's really, really good. And it's not as complex as Event Machine, for example. I think there are going to be questions about it. So I'm preparing myself. Okay, to sum up. Do we want to use Ruby for real time or not? So is it slow? Is it fast enough for us? So we know that WebSockets in Ruby is possible. So we can write applications, that's okay. But if we want to use it for high performance application, we need to bring something else to the stack. Just Ruby is not enough. As for Action Cable, it's usable, and many people use it for small projects, for example, or for MVP projects because they don't know whether it's going to be a good idea or not. And when you face a problem of performance, you can just fix Action Cable or replace it with something else, as I already showed. So we got any cable, we got Light Cable, we got Plezi and Iodine. Maybe someone can write something else on top of it. The idea is to leave all the business logic in your Ruby application, because it's much more easy to write it out there, and to bring all the hard work somewhere else and connect them somehow. That's the main goal of the Anycable and related projects. Well, that's all for now. Yeah. And I got a bunch of stickers. Feel free to ping me if you're sticker fan and you have a place on your laptop to put them on. Thank you.